Continuing.
Chair here. So and maybe you can step up on the chair too. So if you follow the lines down, I'll show you a typical line. There's a line over here that runs back behind over here, and it has a split here. But one comes down into here, and if you look into the trough, you see the water cycles through. So what I try to do is to replicate what happens when the water falls. It precipitates, it creates a stream. The stream flows down, the stream oxygenates the water, while at the same time it filters the water. It helps settle out solids, it creates bacteria that help fix nitrogen for the plants. It does all of these natural functions that it does in nature, and we just replicate that on a smaller scale. And that just cycles down through, and then I have the plants sitting in sand. So if you see the potted plants, so instead of doing hydroponics where I'm dependent upon the actual, directly dependent upon controlling the water chemistry, I use pots with soil and compost, and then I can modularize where my plants are. I can move plants around, I can fertilize some differently than others, I can give some more water than others. I got all those options to be able to do multiple things. So I don't have to just do one crop of this, one crop of that. I can do multiple different plants all in the same system.
Yep.
Now with aquaponics, typically, even with potted ones, I tend to add other things. I add things like this down here, azomite. Highly recommend it. Azomite is a mineral. It's essentially trace minerals. It's all the trace minerals that are concentrated in these mines, and they mine it. And when you submit it, you're basically submitting all of the little things that tend to get leached out of systems.
Yep.
And that's essential. Another essential component is iron, adding some source of iron because it tends to be depleted as well. And so making sure you have enough iron in the system.
What do you do that?
Really I don't have any with me right now.
Do you use the chelated or just the iron?
Chelated iron is the best because then it gets into the system more actively. And it's pretty hard to overuse it, which is nice. A lot of times, another principle that I use, so when I first set this up, I spent 2 years monitoring. I built a digital monitoring system. I knew what the temperature was here and there and everywhere. I tested nitrogen levels. I tested pH all the time. I tested all these things. And I quickly figured out that how everything works. And I quickly realized that the easiest way to figure out whether a system is working well is to look at the behavior of the living things in it. I look at the behavior of the fish. I look at the behavior of the plants. I look at how everything looks, and from the look of it, I can tell whether it's healthy or not healthy. And then I can figure out if something's not right. I can quickly go and research it, figure out what that is, and correct it. Rather than all this work that's spent trying to monitor and manage and try to tweak and manage. Hydroponics is cool if you're doing it as a business and you're going to be doing a crop-based system. Great. And if it's a business, then it's probably even better to do it that way. But for the home grower, somebody that wants to have just the ability to do something with minimal maintenance, that's what this is designed for. It's designed to maximize your time spent doing it rather than tons and tons and tons of maintenance.
Yeah.
Minimal maintenance systems. So, what else? Let's see. So if you want to look at the fish, give you an idea what the fish look like. Look at these. So you can tell a lot about fish by how they behave. If they're not moving much, probably either temperature. If the temperature's adequate for them, then there's something else going on. So you can check certain parameters, and once you learn these things, it's second nature. Like people say, oh, you got a blue thumb or a green thumb. You know what? You just have a little experience, a little bit of knowledge, like goes a long ways, and you start basing it on principles and looking at things from a principle-based viewpoint. It's easy to quickly figure out whether they're healthy or not.
They look pretty
healthy.
healthy.
I would say that's pretty healthy. If they're really, really aggressively feeding, they're healthy. If the fish look emaciated, thin, if they're fighting with each other a lot in ways that are not healthy, you'll see it. Think we can catch one by hand?
Yeah.
You're pretty fast.
Does it hurt them to catch them?
No. Should we catch one? The only thing that hurts is it affects their attitude a little bit.
They get more
They get a
scared?
little bit nervous. They're smart. They're very, very smart. They're very, they know what's going on. They know what a net is. They'll go around the net if they can see it. I've had them literally jump over my shoulder and across the tank or across the greenhouse when I try to catch them because they know. Look at that. Nothing. They're very, very, very smart. So with these, there's what's left of that leaf that I put in there a little bit ago. These are vegetarian fish. They like to eat vegetables and leafy greens. So that's a nice way to use greens that you have. See,
Yeah.
they'll jump right over it. They're really smart.
Oh, you got one. You got one.
Ooh, it's a bigger one too.
So was that like a pound? Or
Maybe half a pound, I'd say. This
so
is a male. Oh, come here, buddy. Oh, it's got eggs. So this is
Holy
this is a
cow.
female. It's got eggs.
wow.
So those are the eggs inside it. And what
How
we can-
many? Like
maybe 50 eggs in there. So what we can do is take those eggs. I'm going to actually just put them right into here.
oh wow. So you're actually taking out.
And the other fish will probably eat them, unfortunately, but I wasn't
And the
prepared.
eggs
I
are-
wasn't prepared to find eggs.
So these are ready to hatch when they're in the mouth.
Yes, so they will keep the eggs in their mouth, and they will hatch, and then the female, they'll actually keep the fry in their mouth too, and they'll protect them for a while. So we're gonna have a good time tomorrow. I think we're gonna get a lot of eggs and fry tomorrow. So, and what we'll do with the fry is we'll catch the eggs and fry, and we'll put them in the small cup. I've got a small incubator cup. I usually just put them in a little like a yogurt cup, and I'll put them in here in some water. And then I'll put this inline right in the system and have flow. Again, you need oxygen. So you have constant aeration of the eggs and a little bit of turbulence. And it'll just flow around in there and then it'll overflow. The eggs will hatch and then the fry will eventually swim out, swim into the trough. And I usually let the fry just swim and live in the trough.
Like for example, where?
I don't have any in there right now. I had them in here. I used to do that here. I used to have a trough system across this whole side. And then I actually had it set up for the fish to rear the little babies, and they would grow to about an inch in there before I would kind of take them out and move them into the rest of the system.
Very nice. What's how many gallons in here?
This is about, right now the water level set, it's probably about 200 gallons, so it's not super huge.
How much?
About
How many
300
fish
bags.
can you get in there?
I've got 160 in there right now, approximately. So, fair amount.
So 2 gallons per fish?
Well, here's
Or
the thing.
you said
that's-
200?
This is not a closed system, so you got to add the water here and there and there and there and outside. All the different. There's another 400 gallons in another tank outside. So, again, that's that buffering capacity. Now, it's not just strictly a water fish-based calculation. You got to look at what your filtration is. With the streams and the nitrogen fixing the nitrogen fixing bacteria, Nitrosomonas and Nitrobacter are rapidly growing in the sand that the stream is flowing through, can break down this fish waste really quickly and turn it into nitrates. The plants can take the nitrates out. I've never got a nitrate reading in here, to be honest. Like, it all gets taken out. So, I've tried. I have to actually add a fertilizer like worm compost to my plants because there's just not enough nitrogen. But that's also because I don't feed my fish a ton of food.
If there's not enough nitrogen, does that mean also not enough?
not enough food for the plant, they need a
Also
lot of
not
nitrogen.
enough. That's an indicator. If there's no nitrogen, is that an indicator that there's all the waste is getting processed, or there could be other waste that's not nitrogen?
It would be an indication of the waste is all being removed, that it's being cleansed out. Because then if there's no nitrogen in the system, it's
Yeah.
being removed and taken somewhere
Okay.
else.
So talk to us
There
about.
could be ammonia in there, but that's usually broken down immediately. Once the
Let's go
system's
through
cycled.
the. Can you walk us through all the places where the nitrogen's getting taken out, the filtration, all that? Can you go through
so
that?
filtration.
Starting from where the waste comes in, and that is fish food.
Yeah. So,
Yeah?
so this is our source. So for nitrogen sources, here's our primary source is the fish food.
That's an automatic fish feeder.
This is an automatic fish feeder.
Demonstrate
I'll
it,
just show you
please.
how it works. So this goes off a couple times a day. I'll modify it a little bit so I can just push this little button here. and it runs down.
Runs down and
And the fish get to eat. They're just eating a couple times. So they're starting to get full.
yeah.
But they're also a little wary because I just threw the net in there, and once the net goes in there, their attitude changes. They know. They're aware. So I also added, this is another thing I'm experimenting with. It's not nitrogen based, but it's kind of cool. I just hung a spoon right here, so that every time that the food comes down, it hits that and makes a ding sound. So they get that same, kind of like Pavlov's dog. Ding, ding. Well, in I think it was in the 70s, the Japanese were experimenting with what's called ranching, where they would raise the fish in pens, and they would play an underwater speaker every time they fed them. And the fish would associate that sound with food. And so eventually they were able to feed them without the barriers and let the fish go out into the ocean. And then what they would do is, every time they ring that bell, the fish would come back in. But then they would let the fish go out, so the fish had the whole natural environment to go eat and get all their food, and they would come back. And then when they were ready to harvest, they get all the nets ready, have it all set and ready to go. They play the speaker, all the fish come in and they get to harvest. So they lose some of it, but they get a lot of natural food sources that way. Now with fish like this, there's our filter feeders. If you could even just connect to an ocean, or connect to a lake, or connect to a pond, you could filter that pond water using the fish. You wouldn't have to use that technique. But I like to do it for fun, just as experiment, because that's just my nature. So,
Okay. Walk through the whole.
So nitrogen. So fish eat the food. The fish excrement and urine turns into ammonia. So that's immediately broken down. These particular fish are very, I keep them hungry. And the reason I do that is because it keeps them constantly checking and filtering to try to see what's food and what's not. They will even pick up their own feces in their mouth, which sounds terrible to us, but to them it's just not a big deal. And they won't eat it, but they will chew it up, and it breaks it up, and it gets carried through the system. So that will break, that's the first part of the system. It helps break down the waste. The waste will be carried through. I use a siphon system to siphon it into here, and this is like a little settling basin. It helps
Siphon, how does it work there?
The siphon, it basically is set up so once these are connected, I basically connect a pipe between these two, and I suck the water through so it creates a suction. Now this water level is dependent upon this water level. This water level drops, it pulls the water.
How'd you
out.
suck it in first?
I used just a tube and I stuck it in the bottom and sucked the water out. Suck the air out, I should say. You can use a flood system. I can show you the flood system outside when we get out there.
Okay.
But I use a flood system to prime this, called priming the siphon. And this is something I've been experimenting with for the last couple of years to figure out how can you build things where you don't have to overflow. Because a lot of my systems, you'll see I have overflows where it just flows over like a stream or waterfall, which is good because you get aeration and stuff, but sometimes it's not practical. And this was a case where I made a mistake. I cut my thing wrong. I cut my liner after I got it all in, which is a lot of work, and I cut it wrong. I cut it too short, and so I had to figure out a solution, and I did, which is the siphon system. Every mistake or problem
is an opportunity.
It really is. It really is. And if you take it that way, it's so cliche, but it's so true at the same time. And when you take it that way, you discover things that you would never have discovered otherwise, and that's what's cool about it. So this also has a siphon-based system that comes out, and that runs down into underneath the floor and into the sump.
Another siphon system?
Yeah.
Where?
It's an overflow right here. So this thing is siphoning.
Oh, yeah.
The water's actually going through this pipe. And it's hard to see without me taking it apart. I can pop it off if you want, but then this will flood all the way up, which is fine. There you can hear it. So this is how it works. So this is how I modified it. So I've got like an extension. This was like a 3-inch to 1.5 inch to 1/2 inch. I've got 3 pieces in here.
Perfect 3D printable material.
Totally, yeah. I tried to do everything that a lot of my stuff that I've done just being able to go buy it at Menards so they can replicate easily. But yeah, 3D printing with that technology now, we can design whatever we want, which is really awesome. But this simple design is just basically put some screen in here, pop it in there, and now I've got a nice filter here. It just helps filter it, keep the solids from going down. And the fish, primarily for the fish, because the fish will get sucked in the drain and they'll clog it up. I'll learn that the hard way. So these little holes here are drilled also so that if this plugs, these can take over. So I've never had this actually plug up since I did this design, which is really nice. And that's another maintenance issue. If you can, redundancy this would be an example of redundancy. So we're using redundant ways to get the water out through the siphon and keeping the siphon going. Because if you have too much air coming through, that'll break the siphon as well. So, and it's going to do that now. So I have no water in here. So it's going to flood before that siphon starts up again. It'll flood up to this level and then it'll start the siphon automatically on that one, which is nice. So I have some small fish in here. They help kind of break it up too and keep things flowing. Aeration, movement. You can't see a whole lot in there right now, unfortunately.
Yep.
But it's only 1.5 feet deep, and there's some smaller fish in there. Helps to kind of segregate the fish somewhat. If you want them to be healthy, it's hard on them. If they're really small, they have a little tougher time finding the food.
Is there a general figure for how big of a fish can eat how big a fish? Is it like 5 times?
I don't really know. I can say this. I've had fish, once they get to about 3/4 of an inch to an inch, I haven't seen those get eaten by anything. Those tend to survive once they're in there. They're big enough to be able to get away. But one of the things that I do is I also provide them natural cover in their tanks. They're not just empty ponds, so to speak. Because, well,
You getting nibbled?
no, I'm touching a lot of fish in here. Because I just stirred it up and they can't see me, but I can touch them. They're not attacking me, which is good. There was another one in here I wanted to show you, but I'll usually take some PVC pipe, I'll drill some holes in it and make some structure for the fish, for the smaller fish. That way they have some place to go and hide from the bigger fish.
That works for them?
Yeah.
How do you know it works?
Because some of the smaller fish will last in there a long time. And once they get to a certain size, when they're really small fry, they just can't swim fast enough to get away. It's not a function of whether they want to.
But they still can get
they
surprised,
will try
right?
to get away, but they just can't. Very rarely. They're pretty smart fish. They really are.
Okay.
But then again, I'm not in there with them all the time, so I can't guarantee anything I'm saying in that regard. Okay.
So flow system continued.
So flow
Initial drain.
Yep. So we got some settling there, but mostly the water goes into the sump, and the pump pumps it up to the water tower, and the water tower filter sends it back out. And so I've got one line here. So for example, this line goes to an outdoor trough system that recirculates the water back. It flows through trough and then comes back into the greenhouse. And this is an inside way of looking at it. I looked at it earlier, but you can see where the line comes in here. It flows out here and then flows around the plants. I've got another little worm compost inline here. This is like a mini one that I was testing when I first tested the inline system.
So you got some worms inline there?
Yeah. Take a look in there. Should be finished compost in there now.
Yeah. And some worms in there too?
There should be.
Don't see much.
They may have moved on if most of the food's been removed. So, but they will migrate throughout the system. I found worms everywhere. So,
yeah,
that needs some food in there. They'll definitely could take that compost out and use it. So the water will flow down here, and where you will see settling is in places where the water slows down. So here's a good example of that, where this is all basically fish excrement that settles out. It does not smell like you'd expect. You'd think it would just reek in here, but it doesn't smell at all, right? Because you've got aeration and oxygenation, and that can break down that stuff. When you have aerobic decomposition, it won't smell. When you get anaerobic decomposition, that's called stagnation. That's great if you want to generate methane for powering something, and you build a methane digester. But in a living system, you don't want that. That's a kind of antithetical to what we're trying to do here. So. And then the water just flows over. Everything's flowing. And then this is where it kind of repeats. And it's a constant flow system. There's no flood and drain or anything like that. It's just constantly flowing. All the plants that you see up here are sitting right either on an embankment of sand that's alongside the stream, so the roots can dangle into the water and get what they need, or they're directly in the water if they're, if they like a lot of moisture. I put them right in there.
Mm-hmm. Right.
And then I've got other things, you know. Like
Should we go outside to look at the external systems?
yeah,
or?
yeah, let's do that. Let's start here. So this is the big tank that tomorrow we're going to be taking all the fish out of the 300-gallon tank in there. We're going to be moving them into this tank.
All of them?
Yep. We're going to go through all of them. We're going to catch all the fish out of there. And we're going to take all the eggs and fry out.
How do you catch the fish?
Just for that, we're gonna have some fun. We'll have to probably siphon a lot of the water out and drain the tank down to get them all out.
Yeah.
And then once we get them all out, we're going to take the fish that we're going to eat because we're going to have a little feast tomorrow to celebrate our
Kickstarter
and our
victory.
aquaponics. Yes. Absolutely.
In
Absolutely.
the upcoming aquaponic greenhouse workshop.
Yes. Absolutely. So, and then we're going to move some of the fish into here for probably the next 3 or 4 weeks. So this is
You have them grow out here outside. That's excellent.
Yeah.
Combining internal and
if I had
outdoor.
if I had a
Man.
longer, warmer season, I would keep them outside longer.
Wow.
But because they're warm, they do better in warmer temperatures. I tend to keep them in there with the water.
Which means that in the 800 square foot greenhouse like we have, we can completely integrate it with outside and just multiply the productivity.
Bingo. Exactly.
Yeah.
Yep. And all
Excellent.
you gotta do is build a pond big enough. And I would recommend a bigger, shallower pond that's easier to work with rather than deep, narrow ponds. You want it to be simple and easy to work
Uh-huh.
with. But then also
Here, can we go on?
design it in such a way that you can easily manage it. So, for example, when I want to catch the fish out of here without some type of help, it's almost impossible to catch them. I have to drain all the water out. So what I did when I want to catch them is I built this screen system that just blocks it off, and it's got this. So basically, I put this on one end and just slide it down the system and corral the fish into one corner, and then I can catch them real easy.
They can leak out of there.
They can't, yeah, because it's stretched out over the last year. But yeah, you can design this a different way. So this, I have a design for another one for a fish catching system where you can basically build a cage where they go in and you just corral them in, and then you just drop the entrance on it and lift it up and take them out with a little catch. Simple. There's
Yeah.
some real simple ways you could do that.
Tell us about some of this plumbing here.
All right, so the plumbing. So this is my feed. This is coming from the water tower.
Oh wow, so that's just from the same
Yep.
water tower.
Yep, it's the same water tower.
That's great.
I have it connected to this is the return, and the return is coming from here. So I've got a same idea here. I've got a filter siphon. Yep, siphon system comes up here, and then what I want to do is if the water
That's
level
amazing.
drops-
Like you got, instead of poking through the containers, because you have a lower place, you can siphon,
yes,
and that's
exactly.
hence the sump on the underground, like the aquifer.
Exactly, the aquifer idea. So it's just using natural aspects of nature's already done it for us. So using gravity to our advantage. Why not?
Mm-hmm.
You know, it's just simple. But it does take some monkeying. I had to do some testing to figure out how this would work
That's
well.
pretty good. Pretty
It's
good.
self-priming too. So now this sometimes when the water level will drop here, this won't prime itself. Like there's not enough suction to pull it to get it to start. So I built in a primer. So I just connected
Wow.
these two together, and all I have to do is just flip this switch, and it will prime. So you can see the water pushing back out. And if I close this
Can you
down here,
explain
you can
that?
see it. So yeah, the water pressure is coming up. This has water pressure pushing this way. And this is running line down there, which runs up into this settling trough and then back into the tank. So this line, if I open this valve, it's going to flood this way. So it's going to flood here, and it's going to flood here.
Oh wow,
And the
that's
whole idea
excellent.
is to flood.
Wow.
This is basically just a easy primer, so I don't have to siphon and suck the water out myself. I can just turn this valve and shut it off. And
So that
it's done.
took you a bunch of iterations to kind of work all this out.
It took me a couple days to figure it out and get it working well.
Yeah. Wow, that's
simple,
a nice
but-
idea here. Because you have the upper channel there, you've got this reservoir here, it can flood it and then self-prime it.
So
Yeah.
when I flip this, the water's going to flood here, and you'll see this water level back up here.
So you turn it on, fills up.
You see the water pressure pushing it back up.
Yep.
Now I'm going to shut it off. So what this is doing is also priming this. So if this had air in it, if this was completely stopped, there was no siphon going on, and it was dead, and there was air in here, this would flood this whole chamber so that it's getting the water it needs to get to that. It
Nice.
just primes it, basically. is what it's
Nice.
doing. And I just shut that off, and that
Wow.
starts the siphon and kicks it in gear.
Man, that's a complex plumbing system you've got everywhere here. That's
Complex
really
but
good.
simple, right?
Very simple,
like
but
simple concepts, principles. Again, it's principles of just, you know. I think we tend, especially in our culture, tend to use force as a means to get things done, but we can use the vacuum to get things done too. And a lot of times the vacuum's simpler, it's easier because nature hoards a vacuum. It likes to fill that space. So just create the vacuum and it'll do the rest.
yeah. Okay,
That's
more
what I did.
more outside systems. Do we go through this? What we've got here, and you integrated with a children's playground.
Yeah, this was built into the children's playground because they had this set up, and I thought it would be. And basically, I always try to work with what I have. It's another principle. Try to work with where you're at, because you can try to force it. I could build all this fancy stuff, but I try to work with what I have, and a lot of times it always fits. You know, for example, these stones, I got them for free. I got the exact number I needed to run from there to there.
Okay.
You know, it's like, it's really strange how that works. But so this is another example of settling. Here's where the waste goes. There's a lot of waste in here. This helps settle out some of the fish waste before it hits here.
And that bump is intentional. Yeah.
Yep, that's intentional to get the water to flow back and forth.
What do you do
So,
eventually? Do you empty it out, put it in the compost, or?
I'll let it dry out, typically in the fall, and then I'll just scoop out all the waste and throw it in the compost bin with the worms, and the worms will eat it. In fact, the worms in my trough will eat the waste as it's in the trough. And they will live in the water, they will come out of the water, and they will deposit their worm castings right on the edges. And I can go and just scoop out big chunks of it and throw it in the plants. I mean, it's
What kind of worms do you have?
composting worms, the red worms.
Red, just
Composting
red
red worms.
wigglers?
Yeah,
Okay.
red wigglers.
Oh,
Yeah.
I didn't know they could live in the water.
Yeah, they're everywhere. They won't live like in the deep water. They have to be able to get out.
Right.
But they can live in shallow water like that. They'll go in there and they'll eat whatever's there, and then they'll crawl out at night. I've seen them at night. I'll go out there and watch them. They'll climb up the side and they'll cast out the fish poop, which is now worm poop, and it's perfectly processed.
Okay, next system, and
All right, so let's move on.
so this is the structure itself. Now this is put into context here now.
Yeah.
Okay.
So now this makes maybe make a little more sense to you. So this is an outdoor trough, which functions just like the indoor troughs, except it's outside. So I use it in the summertime. I move most of my plants out here so they can get more light. And it's shut down right now. I think I lost some water pressure here when I was monkeying with the water, but this will typically run water through it, and it'll function just like a stream, and it'll water all the plants and keep the same principles going.
Mm-hmm. And you like sand at the base, so
I like sand because sand is a good filter. It provides really good substrate for bacteria. Sand filtration is really good for Nitrosomonas and Nitrobacter. As long as you get a good mix of aeration in there. So if the water's aerated well, it works fine. It doesn't work good in static systems that aren't moving and flowing.
Mhm.
But it works well in this case. And it's also easy because I can move it around. It's cheap. I can aquascape it pretty well, and then I have ridges to put the plants on, so they're not. Some of the plants don't like to be too wet. Some love to be wet. Like this one self-seeded. This little bugger here self-seeded itself.
it's a golden berry.
The goldenberry self-seeded itself underneath the fountain there. It just showed up,
Yeah.
and it likes the water. It loves the water. So keep it moist. And this is an example of a goldenberry that I had in the greenhouse in one of these 1-gallon pots, and it literally split the pot wide open. It grew so big it just overdid
And
the
it's
pot.
happy there.
It's pretty happy except for the bugs. These bugs that we got that like this plant. So,
Mm-hmm.
but again, awesome filtering plant. Looks really good. Now another principle. Here's the worms. These are red worms that I was talking about earlier. I use them for my compost. So all the kitchen scraps. So fruit, vegetables, eggshells. Typically try to stay away from any citrus, dairy, or meat. They don't typically like that. And so what I do is I just take it out here and bury it in here. So here's the worms doing their thing.
Can you see a system where you're actually harvesting these for
See-
fish food?
See all the babies in there?
Yep.
Yep,
A
they're
lot of babies.
reproducing like crazy in there. Absolutely. In
How would
fact,
you harvest them in that case?
What you'd probably want to do is have these set up over some type of system where they drop out the bottom or come out the bottom and get into the flow of the stream and end up in the tank. You just have them naturally find their way in there, and they probably do to some degree. I'm pretty sure they do. I've never seen any in the tank. Let me put it that way. So I know
Wow.
I know they get eaten if they do.
Now, to develop a robust system where that happens, then you can think about potentially eliminating fish food.
Yeah. At least if you can get to supplementing. But with tilapia, you can grow things like kale. You can grow plants like broccoli. They love broccoli, and you don't feed them the broccoli. You eat the broccoli. You feed them the leaves. They love the leaves. They'll eat the leaves all day long. So.
Can they survive on vegetarian? 100%.
They do in the wild. So yeah.
But they eat bugs too.
They do, but they could probably survive just on plants, I would guess.
Mm-hmm. Okay, so you got the external beds. We showed the bigger tank outside, interior. Anything else, or
Yeah.
that's
I
That's
think
about it.
I think that covers it pretty well. I mean,
yeah.
I think so.
And the structure is right here, and that's altogether like 600 gallons of water.
Yeah, I would say probably right around 600 gallons. That sounds about right.
One single pump. It's a very
One
nice
pump.
system.
And I think it could be a lot bigger. I mean, this could be easily scaled to almost any size. So,
Yeah.
and I'm working on that. I've got some software written already for building the building. I've certainly got the ideas in place for how to build an integrated, ecologically based aquaponics system.
Where do you publish most of your stuff? Do you use Facebook?
I have a Facebook page, Open Source Aquaponics on Facebook, and I also have an old website that I had called opensourceaquaponics.org, or is it .com? No, .com. Sorry. It's been
Okay.
a while. I haven't updated in a few years because the software I was using to do it kind of pooped out on me, and I just haven't had time to
But
rebuild
we're
it.
having